case study. Remember, for homogeneous, if it's like this, you said is a r squared plus br plus c is equals to 0 to solve this, right? And you can have two solutions. If b squared is greater than 4ac, so there are what? Two different roots. And the two different roots, our solution become y is equals to what? C1 exponential r1x plus C2 exponential r2x. Is this correct? Yes. And then we say if b squared is equals to 4ac, you have just one root. You could call it r. And y is equals to C1 plus C2x exponential rx. And if b squared is less than 4ac, you have complex root. And for complex root, we said that our solution is alpha plus or minus beta I. Our r is alpha plus or minus beta I. So our solution y would be exponential alpha x c1 cos beta x plus, am I right? C2 sine beta x. Okay, now let's move to the non-homogeneous. So for non-homogeneous, there are two methods. F of x is not equals to 0. So if this f of x is not equals to 0, it's non-homogeneous. And there are two methods to solve it. Actually, there's another method called Laplace transform. We'll get to that after spring break. The two methods are variation of parameters, right? Is it variation of parameters? What is it? Yes, am I wrong? Yes, yes, variation of parameters and the undetermined coefficient. So today we are going to solve these 6 questions here with both methods. Actually, we might be able to solve the 6th one of them with the first method and go with the second one. Depending, we keep solving till we solve. So let's start with the first one. This one we've solved it before. Y prime prime minus 3y prime minus 4y is 3 exponential 2x. Did we solve this before in class? Did we? Yes or no? Okay, so we want to use the method of undetermined coefficient to solve this. Now, the first thing you want to do is our solution is y homogeneous plus yp. This yp is non-homogeneous. So it's just, you assume homogeneous first, you solve, then you solve for the non-homogeneous thing. That's how we do it. And then if you assume homogeneous, the way we solve homogeneous is r squared minus 3r minus 4 is 0. That's how we solve the homogeneous, right? This becomes r squared minus 4r minus r minus 4 is 0. It becomes r minus 4 minus plus 1 r minus 4 is 0. So your r is minus 1 of 4. Okay, so the solution becomes this category here because you have two distinct roots and b squared is greater than 4ac. So our solution is c1 exponential 4x plus c2 exponential minus x. That's the first part, right? Now, the second part is, now to solve for yp, we're using the method of undetermined coefficient. And for the method of undetermined coefficient, if f of x is 3 exponential 2x, who can tell me what our yp would be? From the table, what would yp be? Anyone?
Sir, in the second step, it should be plus r, not minus r.
No. What do you mean?
Sir, r square minus 4r plus r.
Yeah, this is plus, you're right.
Yeah.
But regardless, the answer is correct.
Yeah.
Thank you. Yes, who can tell me what yp is? What would yp be? From the table, I gave you a table last week, week 6. Anyone? It's too early to forget. If it's exponential, is what? Yes. Say it.
AE to the 2x.
Thanks. So it's AE to the 2x. it's just a exponential, the number here. That's what it be for yp. Right. Don't worry, we'll solve it using the other method so that if you don't like this method, you can use the other one. So if it's a e to the 2x, right? So we find yp prime because we need to put everything back here, and we find yp prime prime. So yp prime is 2ae to the 2x, right? And yp prime prime is 4ae to the 2x. Okay. So that is why we call it the undetermined coefficient method, because what we're trying to do is find the value of this a here as the solution. So we have this value, so we put it here. So instead of y, we put yp. So y prime prime, now we have y prime prime minus 3y prime minus 4y is 3 exponential 2x becomes, this y prime prime becomes a e to the 2x minus 3. This y prime becomes 2a e to the 2x like this, minus 4. This y prime is a e to the 2x, becomes 3e to the 2x. Great. Okay, so from here, it becomes a e to the 2x. This becomes minus 6a to the 2x minus 4a to the 2x is e to the 2x. You can see e to the 2x is common. Yes?
I think 1 don't count 4a.
Yeah, you're right. Thank you. Catherine, can you see? You're bending your head. Can you? Okay, great. I'll write here. So e to the 2x is common. So if you do that, 4a minus 6a is negative 2a, minus 4a is negative 6a. So we have negative 6a is, there is 3 here. I missed that. It's 3. Because e to the 2x cancels out, right? So a becomes negative 1 over 2. So our yp is this. So our yp becomes negative 1 over 2e to the 2x. This is our yp. So remember now our solution is yh homogeneous from yp. So we find our yh, so we just need to add yp. Our solution becomes yh is c1 exponential 4x plus c2 exponential minus s plus, this is yp here, which is negative 1 over 2e to the 2x. Question? Question? So this is called method of undetermined coefficient. I'm going to solve it using the other method now, and then we compare if we get the same answer. Now, let's use the second method because we have to solve 6 of them using both methods. Now, on Thursday, I will derive the formula for you, but I need you all to go to page 1 of this. I'll derive the formula on Thursday, but let's show how to use it now. Page 1 of this. So, for the variation of parameters, this is how it works. The variation of parameters, what it works is that you do the same thing. Our solution y is y homogeneous plus yp. This is homogeneous, the same way we did that one. And this is the non-homogeneous. Right? So our yp is given as u1 y1 plus u2 y2. Yes. So this is the formula for yp for the other method. u1 y1 for u2 y2. And then our u1 is given as integral minus y2 g of x over w, and u2 is integral y1 g of x over w. I'll derive this formula for you, but not today. Let's solve this 6th question first. So you don't need to memorize this, but I'll show you how to derive that later. So this is what you need to know for the method of variation of parameters. You need to know that your yp is u1 y1 plus u2 y2. Our u1 is this, and our u2 is this. So let's apply it. So the first thing we need to do is our homogeneous solution, y homogeneous is the same question. So our homogeneous remains the same, is the same question. Is c1 exponential 4x plus c2 exponential minus x. That is our homogeneous because it's the same question, right? So what this means is that this guy here is our y1. This guy here is our y2 because we need y2 and y1 to find u1 and u2. The first solution is always our y1. The second solution is always our y2. Because the second order has two solutions. Regardless, if it's in this term here, if it's in this term, you do the same thing, you expand, and the coefficient of C1 becomes Y1, the coefficient of C2 becomes Y2. If it's complex term, it's the same thing. The coefficient of C1 becomes Y1, the coefficient of C2 becomes Y2. It's the same. Now, we have Y1 and Y2, right? So we know that our YP is U1 Y1 plus U2 Y2. So we need to find U1 and U2. So once we find U1 and U2, we plug it here. That is how we solve using the variation of parameters. So before that, we need to find W. Who remember what W is? Who remember? Anyone? Yes.
Y1, Y2 prime minus Y2, Y1.
Yeah, it's called the Wronskian. You're correct, right? W is the Wronskian. We talked about that. So it's correct. So it's Y1, Y2, like the determinant, Y1 prime, Y2 prime. This multiplied by this minus this, which is Y1, Y2 prime minus Y2, Y1 prime. Remember, when I taught you Wronskian, I told you that you can use it to solve non-homogeneous. I'll show you. I also told you that it can be used to determine if two solutions are independent solutions of a differential equation. So these are Wronskian. So this becomes, if we do that way, our y1 is exponential 4x, right? So it becomes exponential 4x multiplied by our y2 prime. This is our y2. y2 prime becomes a minus exponential minus x. So this becomes minus exponential minus x, because if you differentiate this, this minus comes over. Then minus our y2 is exponential minus x, right? And our y1 prime is 4 exponential 4x, because if you differentiate exponential 4x, it becomes 4. So we have 4 exponential 4x. So that gives us, this becomes negative exponential 3x. Is this correct? Because this is 4x minus x is 3x. Then minus, this gives 4 exponential 3x. That gives minus 5 exponential 3x. So we find our Wronskian. So now let's go back to these guys here and put the value. Question. You differentiate with respect to x. Integral minus y2 g of x over Wronskian dx. That's the noise. Okay. Does anyone know what g of x is? Who knows what g of x is? Anyone? Yes. Yeah. G of x is always the non-homogeneous term, which is this. Don't forget that. Thank you very much. That's g of x. So it becomes negative integral. Let's remove this minus it. Y2. Our y2 is exponential minus x multiplied by. This is noise. Okay. G of x is 3e2x divided by Wronskian is minus 5e3x dx. Okay. Yes. Question. You agree with me that this negative can get rid of this negative? And then this is negative x. Negative x plus 2x is x. And x minus 3x is minus 2x. So that becomes integral e, you can bring this 3 over 5 out, e negative 2x dx. Okay. Question. And you can also try it yourself in case you think I missed something. Because it's very easy to miss something if you're solving on the board. 2 minus 1 is 1, 1 minus 3 is minus 2. So when you integrate this, it becomes 3 over 5 times minus 1 over 2, right? E negative 2x. That's what it becomes. Let's keep the arbitrary constant now, because we don't need it now. So that becomes negative 3 over 10 e negative 2x. So that is our u1. We keep that. Let's find our u2. Okay. Our u2 becomes, our formula for u2 is integral y1 g of x over Wronskian. And you do not need to memorize this, because this class is not for memorizing formula, you do need to apply it. You also do need to learn how to derive it, which I will do on Thursday. So here our y1 becomes integral exponential 4x. G of x is 3e2 of x over 1 squared is negative 5e3x, all the x here. Okay. So we can bring this negative 3 over 5 out, integral. This is 4 plus 2, 6. 6 minus 3 is 3 because 4 plus 2 is 6 minus 3 is 3. e3x dx. So once you do that, this becomes negative 3 over 5 multiplied. If you integrate, this is 1 over 3 e3x. So this 3 cancels 3. That becomes negative 1 over 5 e3x. So that is U2. Okay. Question. Because it's YP we're looking for. So YP becomes, our U1 is negative 3 over 10 exponential negative 2x multiplied by our y1 is exponential 4x, right? So we can put this in big bracket like this. Then plus our u2 is negative 1 over 5 exponential 3x times our y2 is exponential negative x. Okay. So this gives us negative 3 over 10. 4 minus 2 is 2. So that's exponential 2x here. Plus this is negative 1 over 5. This is 3 minus 1 is 2. Exponential 2x. So if you do plus times minus is minus. So we have minus 3 over 10 e2x minus 1 over 5 e2x. So that becomes 10 here. That is minus 3, right? Minus 2, all e2x. That is minus 5 over 10 e2x. This is minus 1 over 2 e2x. Now we find our yp. This is our yp. This is the same as this guy from the other method. Okay. Which method is easier? We've done this several times. This is the same function. We're not changing that. So now what we're changing is this, and we're using method of variation of parameters, which is we want to find yp, which is u1 y1 plus u2 y2. Our u1 is this, and our u2 is this. We just need to find our Wronskian. Our Wronskian is also going to be the same as this. We don't even need to solve it because they have the same y1, y2. It's the same, right? So it is negative 5 e to the 2x. Is it 2x? E to the 3x. Does that make sense? It's the same question as the previous one, except that this guy is the one that changed. So they would have the same y1, y2. If you do the Wronskian, it's going to be the same. So we know our y1 is exponential 4x, y2 is exponential minus x, and then we know our g of x. Some textbooks use g of x to represent f of x. Sometimes I mix them up. I apologize for that. It's 2 exponential minus x. So we have everything. The key thing about this method is sometimes integration could be annoying. Sometimes it could also be complicated. Other than that, it's just plugging in everything into the formula. So let's see. Our u1 is negative integral y2 g of x over the Wronskian dx. That would be our g of x is 2e negative x divided by Wronskian is minus 5e3x, then dx. This is what we have. So this negative can eliminate this already. Then we have negative x and negative x is negative 2x. Negative 2x minus 3x is negative 5x. So we have 1 over 5 integral exponential negative 5x dx. Right? That one gives minus 1 over 5, sorry. It gives 1 over 5 multiplied by minus 1 over 5 exponential negative 5x. That would be minus 1 over 25 exponential negative 5x. Did anyone get this? Who got this?
Wouldn't it be 2 over 5 outside the integral?
There is a 2 there, you're right, this 2. So this is 2. If you get 2 over 5, put up your hands. 2 over 25. Okay, if so many people got it, it means this is correct. You won. Thank you. Let's do U2. Integral y1 g of x over rho square dx. I don't even need to memorize this. I just need to know if it's U2 you're using y1. This 2 doesn't change. If it's U1 you're using y2 here. This 2 doesn't change. And a negative there. That's how I remember it. That would be integral y1 is exponential 4x multiplied by g of x is 2 exponential minus x. Rho square is 5 exponential 3x dx. Excuse me. 4, let's bring this out. That would be negative 2 over 5 integral exponential. This is 4 minus 1 is 3. And 3 minus 3 is 0. Right? That's exponential 0 dx. Exponential 0 is what? 1. Integral 1 dx is what? X. Right? If you don't know that, let me show you how it is x. Let's go the old school way. So that's minus 2 over 5 integral x raised to power 0, because x raised to power 0 is 1. Right? So dx. So if you want to integrate x raised to power 0, it becomes minus 2 over 5 x raised to power 0 plus 1 over 1 plus 1. No, 0 plus 1. That would be minus 2 over 5x. That's how I got the x. Put up your hands if you got U2 as minus 2 over 5x. Great. So we are making progress. Okay, I'll circle this. So this is our U2. So we have our U1 and we have our U5 exponential. What's there? What's there? Somebody help me out. What's written there? Is exponential what?
Negative 5x.
Negative 5x. You can check your note. Our y1 is exponential 4x plus our u2 is, what's u2? Who is following?
Negative 2/5 x.
Negative 2 over 5x like this, right? Our y2 is exponential negative x. That's what we got. So that becomes negative 2 over 5 exponential. If you add this is negative x, right? 25. Minus 5 plus 4 is minus 1. So then minus 2 over 5x exponential minus x. Right? Is that what you got? Am I missing something? Put up your hand if you got this. Okay. So let's put everything together. So this is our yp. This is correct. So our solution becomes y becomes c1 exponential 4x plus c2 exponential minus x minus 2 over 25 exponential minus x minus 2 over 5x exponential minus x. If you solve it using the other method, which is the method of undetermined coefficient, this guy would not be there. This guy would not be there. Other than that, everything is correct. So one of the limitations of the method of derivation of parameters is sometimes you get an additional term that is created from the constant, from this constant. Sometimes, but you would still get the original solution, but you get that additional term. That's one of the limitations. Sometimes you do. But this is correct. So if you solve it using the other method, which we did on last week, you will see that the answer is minus 2 over 5x is to the minus x, right? And I gave you the same question in the test. Okay, question. Question. 4x squared minus 1. Okay. So, here, this is not exponential. This is a polynomial. Right? First of all, the homogeneous solution, your solution is y homogeneous plus yp. We already did this because this is c1 exponential 4x plus c2 exponential minus x. It's the same question. We've solved it before. Now, for homogeneous, who can tell me what yp would be? For polynomial, does anyone know? If you check the table, last week I gave you a table, right? What would yp be? Does anyone have an idea? ax squared plus bx plus c. Check that table because it's an x squared polynomial. If it's s cubed, it's going to be as cubed plus bx squared plus cx plus d. Like that. I think the problem with this method is figuring out what YP would be to start with. That's the problem. But once you figure it out, you can solve. So what that means is we have undetermined coefficient A, B, and C, which we have to solve for. And we do it the same way. We say YP prime and YP prime prime. We need to find YP prime and YP prime prime, and we plug it into here to find those coefficients. For YP prime, it becomes, if you differentiate this is 2ax, if you differentiate this is plus b, right? And then if you differentiate this, you have 2a because b is a constant, is 0. So we have these two. Let's plug these two inside our original equation. Okay. Question before I continue. Okay. So if we plug it inside our original equation, let's use it. It becomes y prime prime becomes 2a minus 3y prime minus 2ax plus b, right? Then minus 4y, which is ax squared plus bx plus c, would be 4x squared minus 1. So let's expand this. So that gives us 2a, this becomes minus 6ax minus 3b, right? This one gives minus 4ax squared. This gives minus 4bx, then minus 4c is 4x squared minus 1. Question. So all we need to do is put the x squared together, put the x together, and put the constant term together. This guy is x squared. Do we have any other x squared there? No. So we have minus 4ax squared. Let's put that one together. This guy is x here. And this is x here. So that becomes minus 6ax minus 4bx. Right? The constants are plus 2a minus 4c is 4x squared minus 1. Okay. So the way this works is you compare x squared to x, and constant to constant. So this could be written as minus 4ax squared. Then this could be minus x into bracket 6a plus 4b. Then plus 2a minus 4a is 4x squared plus 0x minus 1. This could be written like this because 0x is 0. Okay, so you compare x squared to x squared. So this has x squared, this has x squared, this has x, this has x, and constant has constant. So that's how you do it. So you can say minus 4ax squared is 4x squared. Right? So x squared can eliminate x squared and a becomes minus 1. That's how you do that. Then you can also say minus x 6a plus 4b is 0x. Okay? That's algebra. So you can say 6a plus 4b is 0. Six times minus 1 plus 4b is 0, right? So minus 6 plus 4b would be 0. So 4b is 6, right? And b would be 6 over 4, which is 3 over 2. Is that correct? So I want you all to find c. So if you want to find c, you could say here 2a minus 4c minus 3b is minus 1 because you're comparing with the constant. 2a minus 4c minus 3b is minus 1. So you find c and tell me what c is. Minus 3 times b is 3 over 2 is negative 1. So that gives negative 2 minus 4c minus 9 over 2 is negative 1. So we just flip it over to become, you can keep solving yours. So we compare our answers. That will be better. So if you flip it over, it becomes 4c is negative 2 minus 9 over 2 plus 1. So that gives negative 4, negative 9 plus 2. Okay, that gives minus 11 over 2, and C becomes minus 11 over 8. Did you get the same? Okay, great. So we have ABC. Our YP is AX squared plus BX plus C. That becomes minus X squared. A is minus 1, right? Plus B is 3 over 2X plus C is 11 over 2, negative 11 over 2. So our solution Y becomes C1 exponential 4X plus C2 exponential minus X, then plus all this minus X squared plus 3 over 2X minus 11 over 2. This is the solution to that question. That's quite long. Isabel.